This problem is going to show you how to solve problem number 55 from the chapter 4 homework in the textbook. The gross domestic product, GDP, is the total value of goods produced and services provided in a country during 1 year. Below is a table showing the United States GDP in millions of dollars for every other year from 1929 to 2017. So here's my data that we happen to have. I'd like to use technology to create a scatter plot for the data. I'm going to go ahead and use a TI-83 Plus. When I go into this, I'm going to actually put my data into the calculator using the Stat menu, which is the STAT button. I'm then going to go in the Edit menu. I'm going to go into number 1, Edit. If you happen to have data already in there, you want to clear that data out by going up on the name, hitting Clear, and then hitting Enter. So moving up onto L2, hitting Clear, and hitting Enter. Once I've done that, I then need to type the data in. So I'm going to type the year into my input and the GDP into my output. So year, I'm going to put in L1, and L2, I'm going to put in GDP. I've actually already typed the data in already. You will now type your data into your calculator, but I've already got my data in there for me. So I'm going to put mine in there. There's my years in there, and I'm going to put my GDP in L2. And there's all your data in there for all that you want to have. Now, the next thing you should do just to make sure is press the Y equal to. Everything in this row is where we do graphs. The Y equal to actually gives, I want to see if I have any data already in there or any equations already in there. And I do, so I'm going to clear those out just by hitting the clear button. And then I'm going to go into stat plot because I want to plot the things that are in my stat menu. So stat plot's above the Y equal to, so you hit the second button and the Y equal button. Then go into number 1. You want to turn it on if it is not already on just by hitting enter on the on. You want the type to be the very first one, so you just hit enter on that if it's not already dark. Your X list should be L1. Your Y list should be L2. That's where you put your data in. And your mark and the color is up to you. Now I'd like to plot this, so I'm going to go to Zoom, and Zoom helps me set up the right window. Zoom Stat will actually set up the window based on the data I put in. So I'm going to use that one. You can either arrow down to number 9 and hit enter, or just press the number 9. And there's my data. Now, one of the things I noticed is a lot of the data points look like they follow on the same line, but I have 2 points that are kind of off from each other. They could be real points that are off like that, or it could be some values that are kind of not correct. So we want to kind of just make sure we didn't type something in wrong. So I'm going to hit the trace button to kind of trace along. The trace button is in this upper row. Again, anything in this row is for graphing. If I use the right arrow, I can arrow along on those buttons. What this does is help me figure out which data value this is. And I see it's the 1983 data value. Looks like it might be a little off. And then the next one that looks really far off is then 2009. So 1983 and 2009. I'm going to go into the stat menu again, where I type the data in, go into edit. And this is basically like a spreadsheet. So you can actually arrow down through these till you find 1983. And then you want to check to see, does 1983 the correct value? So over here in my data table, 1983 should be 3634038. And I don't have that. I have 363438. I lost my 0. I'm going to retype this one. You can just type it, 3634038. That fixes that value. Again, it could have been a real value. It's just, it seemed a little weird. So I wanted to check it out. The other one was, I believe, 2009. So we're going to go look at what 2009 was. And that one should be 1444892. And it looks like I didn't have enough 4s. So I retype that one, 1444, and it was 8932. I do want to mention that some of these look a little weird, and that's because the calculator can't write them all. So it writes them in scientific notation. But as you see, when you arrow and we're over them, they are the right value. All right, so now I can go back to graph, and they all look like they fought nicely along. All right, looking at this graph, I now want to use technology to create an appropriate model. And the model it looks like it looks like it comes along, and it looks like just keeps going up from there. So this looks like exponential. So it's like exponential growth. So I'm going to go into stat, move over to calculate, and then, which is the CALK. And I'm going to go down and I'm going to do what we think is exponential growth. A model is done by regression. So we're looking for the different regressions. We have a linear, LIN regression, which is linear regression, QUAD, which is quadratic regression, cubic regression, quartic regression, another linear regression, sorry. Some people like it AX plus B, some people like A plus BX, they're the same. An LN regression, which is a natural log regression, an exponential regression. So that looks like the one I want. EXP stands for exponential. So I'm going to go into that one. I want my X list to be where I put my input values, which is L1. My Y list should be my output values, which is L2. Don't worry about the frequency list. I would like it to store the equation in some place. I'd like to store it in my Y equal to. It's a variable. So I'm going to hit the VARS or VARS button or variables button. I want to put it in a Y variables. And it's a function I'm going to work with. I have all these different ones I can put it into. You can do it any one you want. You might as well just do the first one. And that means it will take, once it calculates it, it'll store it there. And so now we go down to calculate, hit enter, and it then calculates that value for me. I can now see that my equation is Y equals A, which is one parameter, which is 5.49. E means times 10. So times 10, and then the negative 0.54 means negative 54 power. So this is actually 5.49 5, because I don't want to round it off too much, times 10 to the negative 54th. And then that's going to be times my B, which is 1.072 to the X. Now I want to put that in parentheses just to remind myself it's the whole thing to the X, to that power. All right, there's my equation, there's my model. They also would like me to find out the R squared value. The R squared value is right here. It actually gives it to me. It's R squared is equal to 0.987. So that's my R squared value, 0.987. And that is interpreted as 98.7% of the variability in the GDP is explained by the model. So that's pretty good because that's pretty high up. They are not always this high. This just happens to be some data we have that happens to be really good. Now I'd like to use the model to estimate the GDP in 1990. I'm going to go ahead and look to see, did it actually save it in Y equals? So let's collect the Y equals. If there's my equation, exactly as I have it. It doesn't round it off, whereas we rounded it off. Makes life a little bit different, but that's no big deal. I'm going to go ahead and graph it, and I can now see how well did that model kind of fit the data, because you can see that the graph and you can see the data is there, and you can see it kind of fits it pretty good. Not great, but pretty good. All right. We're then going to use the model to estimate in 1990. So we can do this actually by clicking on second and the CALK, calculate. And I can do it for a certain value. So number one is a value. And I can put in my value of 1990. Now you're going to look in our data. 1990 is not there. So I can't just read it straight off the data set. But I can use this model to calculate. And that's what we do, is we use these to calculate. I'm going to hit enter. It puts it there so I can see the data is actually there. It tells me what it is. And it says the GDP for that is 4613126.6. And this is in millions of dollars. So you want to put that units down. Just make sure people know what you're talking about. So that's pretty good. We want to know if it can be trusted. Well, 1990 is actually part of the range of the data. Though we don't have 1990 actually in here, a data value of 1990, there is a data value of 1989 and a data value of 1991. So that means that we're following along with the data already. So it can be trusted because we're inside the original range of data. So that worked out. You could actually see it. I like this because it shows it right there on the graph. We can also use our model to predict in 2050. I'm going to show you a different way. And actually, it's a better way because 250 is not on my graph, so I can't use my graph to do it. But I can actually go back to the original data and to the main screen. So second, quit. I then want to use that function I typed in. So I'm going to hit that vars button again, go over to y vars, and it is a function. And I put it in y1. And I'm going to use functional notation. This is the name of my function. It's going to be f, it's y1. Put a parenthesis to say I want you to calculate what this is. And then you can put in what you want to calculate for. And then close your parenthesis. And there it is, what the GDP is in 2050. So that one would be in 2050 is 295,603,080,870 millions of dollars. Now, we want to know if we can trust that value. Well, 1950 is not part of my data set. I don't even see a 1950 anywhere in here. In fact, we haven't hit, I'm sorry, not 1950, but 2050. We haven't even hit the year 2050 yet. So it probably shouldn't be trusted. We don't know what's going to happen. There could be some things happening, like a recession or other things that could happen that could change what that is.